Yes, dear students, here we are starting our wave motions chapter. That is chapter 25, waves we are starting. Okay, only one chapter there. In this unit, only one chapter is there, waves. Okay, actually it is oscillations and waves. So here we are starting waves. Ready? Okay, straight away let us see the objectives. We are going to study which are the two types of waves, equation of wave and relation between particle wave velocity and wave velocity. Okay. Now this is about waves, it's okay, but the previous chapter was something related to waves, isn't it? Moving up and down, moving back and forth, remembering? Fine. Just recall those things. What type of waves we have studied? Yeah, simple harmonic motion. And as applications of simple harmonic motion, so much of movements we have studied, simple pendulum as well as spring, isn't it? Okay. Similarly, in connection with that, we are going to study wave motion. So, waves we are going to start. Actually, waves, wave motion, which picture is coming into your mind? Yeah, moving up and down. Okay, moving up and down. That means energy is moving forward, but the particles are moving up and down. That is what is happening when the ripples are forming, right? Yeah, when ripples are forming in a pond, what is happening? One paper boat is there. When we are putting a stone into that, ripples will be forming. But all on a sudden that paper boat is not reaching the shore. Ripple is reaching the shore, ripples is touching there, but the paper boat will be moving only up and down. Am I right now? Yeah. Why? Because particles are moving up and down. Since the particles are moving up and down, the paper board which is just above those particles also will be moving along with the particle. But the energy is reaching the shore, isn't it? Yeah. So when these particles, with the help of these particles, energy is propagating, those waves are having one name. What is it? Fine, mechanical wave. Okay, mechanical wave. What is the specialty of mechanical wave? It requires a medium for its propagation, right? So, mechanical waves means it needs a medium for propagation, and there are two types of mechanical waves also you have studied, I hope, isn't it? Which all? Yeah, which all are the two types of mechanical waves? Surely you know that. Mechanical waves are of two types, they are transverse waves. Now you are remembering now, as well as longitudinal waves. So transversal and longitudinal waves are the two types of waves. Now we are going to see that type of waves as well as particularly about the sound wave. Sound wave is, it is longitudinal or transversal? It is longitudinal wave. Okay. So beginning generally we are studying, then about sound wave we will be studying. Okay. So two types of waves are there, longitudinal wave and transversal wave. We will be sticking on transversal wave mostly. Okay. Okay, let us see about that waves here now. As I said, longitudinal wave and transversal wave. Longitudinal wave means it will be propagating along the direction. It will be means particle will be propagating along the direction of energy, moving parallel to each other. So, when these types of motion happens, compressions and rarefactions are forming. Seem to be compressed, then rarefied. Likewise, by making compressions and rarefactions, energy is propagating. But in the case of transversal wave, particle like ripples, particles are moving up and down. So, their crust and trough is forming. Okay. So, these two types of waves already you have studied. I am just refreshing that, longitudinal wave and transverse wave. With this picture, it will be very much clear, isn't it? See, top it is given transverse wave. They are more particle is moving up and down, energy is propagating in the forward direction. See the downward one, red colored particle, that is moving back and forth because in the direct compressions and rarefactions are forming, the dark color is seem to be crowded, that means compressions, soon after that rarefactions. So by forming compressions and rarefactions, energy is propagating forward, particle also moving along the same direction, back and forth direction it moves. Okay, so whether it is compressions and rarefactions or crust and trough, what is happening? Amplitude wise it changes. So normally a wave can be, generally a wave can be represented by the change in amplitude. From mean position, it is amplitude is changing, so displacement is changing, and the maximum displacement is called amplitude. So related to waves, generally the wave can be shown like this. Two types of waves are there. We are talking generally. Generally we can represent the wave like this. Okay, and when we are taking the maximum displacement of the particle from the mean position, it is called as what? Amplitude. Then when we are considering the distance between two crust or distance between two trough is called its wavelength. Okay, then what else you studied? Time period, time taken to complete one wave is called a time period. Inverse of that is called frequency. All these we have studied. Now one more thing we are going to see, that is relation between velocity, frequency and time period. Velocity of propagation of the wave, frequency of the wave and lambda. Lambda means wavelength. Okay, that is when we are taking the distance travelled by the wave, in one complete time period. Okay, distance travelled by the wave in t seconds is wavelength. Okay, then distance travelled by the wave in 1 second, which is called velocity. Distance travelled by the wave in 1 second, that is velocity is equal to then what? Lambda by t. What is 1 by t? Frequency. So we can write V is equal to f lambda, or instead of f we can use the symbol n. V is equal to n lambda. This is the relationship between velocity, frequency and wavelength. All those things, all the other things you know, what is amplitude, what is frequency, what is time period, wavelength is represented by lambda, all those things you know. This is something new to you, relation between velocity, frequency and wavelength. V is equal to f lambda. Okay. So just with the help of this picture, just you identify what is wavelength, what is amplitude, and also that relationship also given there. V is equal to f lambda. Clear? Okay then. Now along with this, next one is, another important one is phase. Heard about that? P-H-A-S-E. Another important term is phase. That is when particle is vibrating, when we are taking two particles like this, both are having the same displacement from the mean position. Okay, after completing one wave, from the mean position how much is displaced by A, B also in the same manner. So their positions are same. Okay, indicate their position of those particles are similar, right? Then it is called A and B are in phase. Okay, they are having the same displacement. Thus, position of a particle is explained by a term called phase. Okay, position of the particle can be explained by a term called phase. Okay, now when we are taking a particle A there and C here, one is at the top extreme, other one is at the bottom extreme, will be called as out of phase. They are not in phase, they are out of phase. Exactly 180-degree difference means it is called out of phase, opposite phase. Okay, so according to the position of the particles, we can say that means position of the particle is represented by a term called phase, right? When we are considering two waves, If their starting point is different, we can say they are having a phase difference. And usually phase difference is represented by the letter phi. When we are taking the phase difference between the 2 points, corresponding difference along the length is called path difference. Okay, so phase difference as well as path difference there, both are indicating the position as well as direction of the particle undergoing wave motion. Okay, so just see this and make it clear. As I said here from this diagram, B and F are in phase. B, F, J, N all are in phase, but BD out of phase. Okay, right? A and E, they are in phase. Likewise, which all are at the after completing the same angle or having the same displacement, such points can be called as, or it is represented by the term called phase. Next picture you see, with the help of 2 diagrams it is shown. One, the particle is at one position, next case particle is at the other position. So what is the difference in those positions? That is represented by phase difference. And also that phase difference is represented in the diagram, it is given as 1/4 of lambda is the phase difference. That means phase difference can be represented in terms of angle or in terms of distance. And the relation between phase difference phi in terms of angle as well as path difference, which is expressing in terms of meter or distance, that is given there, phi is equal to 2 pi by lambda into x. Okay, phi is equal to 2 pi by lambda into x. I will make that clear. So look at here, when the wave is having a distance travelled as its wavelength lambda, then how much will be the angular movement? 180 degree plus 180 degree, 360 degree. So when phase difference is lambda, path difference will be then 2 pi. Okay, then if the phase difference is only 1 centimeter for unit length, it can be written as 2 pi by lambda. For any distance x, then the angle rotated will be 2 pi by lambda into x. This is what is called phi. If the angle is phi means for any distance x, that means if the path difference is x, corresponding phase difference is phi and the relation is 2 pi by lambda into x. This relationship should be by hearted. Okay, phi is equal to 2 pi by lambda into x. Clear? Okay, then now let us see equation of wave. Already the equation is studied. Different forms of the same equation we are going to study. Okay, yeah. How did we represent the equation of a wave? Y is equal to A sin omega t. Something else is there? Starting from the mean position, then omega t only. Otherwise we have studied plus phi, minus phi. Okay, here generally let us write omega t either plus phi or minus phi. Now I am writing omega t minus phi. Okay, A sin omega t minus phi to express a wave, equation of a wave. Right? Now we have studied phi is equal to 2 pi by lambda into x. But for 2 pi by lambda, one term we have studied, that is kx. When SHM we have studied, there we studied 2 pi by lambda is can be written as k. Right? So here when we are writing y is equal to A sin omega t minus phi, or we can write A is A sin omega t, phi is equal to k into x. So we can write k into x. Another form, or A sin omega means what? 2 pi by t, formula we have studied. Can apply 2 pi by t into t minus what is k? 2 pi by lambda into x. When 2 pi by lambda into t by capital letter T, here 2 pi by lambda into x. But 1 by t is what? Frequency. relationship between velocity, frequency and lambda we have studied. If we are writing instead of frequency time period, v is equal to lambda by t. Okay. Therefore, instead of 1 by t here, we can write v by lambda. Okay, 1 by t is equal to v by lambda. 1 by t, v by lambda. Just replace a sine 2 pi instead of 1 by t, v by lambda. So, v by lambda into t minus 2 pi by lambda into x. So, 2 pi by lambda is common. We can take 2 pi by lambda outside. So, how will it be? A sine 2 pi by lambda outside Vt minus x. This is the common form we are using, a sine 2 pi by lambda Vt minus x. Okay, these are various forms of the same equation. Just see the steps once again. You go through it. How did we substitute? Each step. Okay. All the steps are okay? Right. Shall we move to the next one? Okay, then we are going to see the next one, that is relation between wave velocity and particle velocity. Now, wave equation we have studied now. Which one I said as the common? A sine 2 pi by lambda Vt minus x. That is, displacement can be explained in terms of time as well as in terms of position, time and displacement. So, with respect to y, the displacement with respect to time as well as with respect to displacement, x also we can explain. So, here is the wave equation. Okay, I am going to take the derivative of the same with respect to time, dy by dt. By taking the derivative of this, derivative with respect to time. So, how will it be? D by dt of this means a sine 2 pi by lambda Vt minus x becomes a cos 2 pi by lambda Vt minus x. But since Vt with respect to t means 2 pi by lambda into Vt also to be taken, right? So, a cos 2 pi by lambda Vt minus x into 2 pi by lambda into Vt, its derivative is 2 pi by lambda into V. Okay, that is the derivative with respect to time. We can take the derivative with respect to x also. With respect to x, then how will it be? A cos 2 pi by lambda Vt minus x into 2 pi by lambda into minus 1. Okay, with respect to x when we are taking the differential. Let us write a cos 2 pi by lambda into the whole term first. Then taking the derivative of something coming along with sine function, taking the derivative of that. Vt we don't want, we want to take the derivative with respect to x. So, it will be negative 2 pi by lambda. Okay, let us divide these two, that is dy by dt divided by dy by dx. After dividing, a cos 2 pi by lambda Vt minus x, 2 pi by lambda cancels. So, what is getting? Negative V. Okay, or dy by dt. Y is indicating displacement of the particle in wave motion is equal to negative V into dy by dx. It is the relation between particle velocity and V, wave velocity. Okay, particle velocity is equal to wave velocity into slope of the curve. Y with respect to x means slope. Okay, y with respect to x. That is a relation between particle velocity and wave velocity. Clear? See the steps once again. We have taken wave equation. its derivative with respect to x, that means displacement by time, velocity we are getting. Then derivative with respect to x also we are taking, that means we are getting y with respect to x. So displacement y with respect to x. So displacement in y direction with respect to x direction we are getting. So by dividing and all, we are getting particle velocity is equal to wave velocity into slope of the curve, displacement curve. Clear? Okay? Right? So about wave we have studied something related to that. Okay? With that, going to wind up today's class. See all those things what we had studied now? Just recap. Yeah, different types of waves we have studied. Then equation of wave and its various forms. Also relationship between particle velocity and wave velocity. Okay? Okay, so after studying all these portions, you have to give the answer of these questions given in the worksheet. Write all these answers in your notebook after studying. Okay? Okay. Okay, then let us meet in our next class. Study well and thank you so much.